Hello, today we are going to talk about the law of universal gravitation, so let's get started. The law of universal gravitation was formulated by Isaac Newton in his work Philosophiae Naturalis Principia Mathematica, published in 1687. This law is a fundamental element of classical mechanics and contributed significantly understanding the movement of objects, celestial bodies, and their interactions. The law states that two objects with mass attract each other with a gravitational force proportional to the product of their masses and inversely proportional to the square of the distance between them. The mathematical formula which expresses this law is F is equal to g.frac m1.m2 or 2, where F is the gravitational force between the two objects, g is the universal gravitational constant, m1 and m2 are the masses of the two objects. R is the distance between the centers of mass of the two objects. The gravitational constant g is a universal value that establishes the size of the gravitational force based on units of mass and distance. The values of the masses and distances of objects are measured in kilograms and meters. A key aspect of this law is that gravitational force acts between any two objects, regardless of their mass. However, the larger the masses and the smaller the distance between them, the stronger the gravitational force becomes. For example, although the Earth and the Moon have different masses, they attract each other due to gravity. This law has had a profound influence on our understanding of the motion of the planets around the Sun, the motion of the Moon around the Earth, and many other natural phenomena. This was also confirmed by later observations and experiments, including Johannes Kepler's observations of planetary motion. Gravitational force is an attractive force that acts between two objects having mass in the universe. This force is responsible for the movement of the planets around the stars, the movement of the Moon around the Earth, and many other observable phenomena in the cosmos. An important aspect of the law of universal gravitation is that this force acts instantaneously, regardless of the distance between objects. However, since light has a finite speed, we observe astrophysical phenomena with a slight delay. Additionally, the law of universal gravitation helps us understand why objects fall to Earth and why planets revolve around stars. This concept has been confirmed by numerous observations and experiments. For example, the motion of the planets in the solar system conforms to this law and could be predicted and verified mathematically. In a more abstract way, the law of universal gravitation paved the way for the development of celestial mechanics and a deeper understanding of the interactions between bodies that you demand. This concept revolutionized the scientific thought of that time and laid the foundations for what we now call classical physics. In conclusion, the law of universal gravitation is one of the fundamental pillars of modern science. It explains how objects with mass interact through the force of gravity and gives us deep insight into the motion and structure of our universe. One of the remarkable results of the law of universal gravitation is that it provided an explanation for the motion of the heavenly bodies within the solar system. In the 17th century, Johannes Kepler developed the laws of planetary motion, and Newton was able to explain these laws through the law of gravitation. Also, the law of universal gravitation played a significant role in the development of Newtonian mechanics. This is a branch of physics that deals with the study of the motion of objects and the forces that influence them.